So now we know that our unknown compound is caffeine. Why is it important that we know how much we are consuming, and what is caffeine in that we consume? So first of all, let's have a look at the functional groups of caffeine. You can see that we have our amine at the top, and down to the bottom we have two admades. That because of these groups, it ends up being nonpolar. This is really important for when we're looking at our compound going into the HPLC machine, because this will help us to determine if we should be using a polar or non-polar mobile phase. Here is an overview of our HPLC. You start with the degas solvent. It's really important that the solvent doesn't have any air bubbles because it can do damage to your column. That then gets pumped through to make it high pressure. You then inject into the port your sample, and this is then placed into the column at high pressure. The column then pushes that through and separates the sample depending on whether it's polar or non-polar. In our case, we're using a polar mobile phase. So therefore our column is a non-polar. This means as our caffeine molecule moves through the column, it will be going slowly, which means you can start to separate. Then it heads out down to through the detector, where you can then get your chromatogram. Caffeine has an absorbance at 260 to 270 nanometers. This is really important to know what wavelength it absorbs at, because it allows you to program your HPLC to have the UV detector detecting at this particular wavelength.